So, hey, Jonathan.
Adam, thanks for having me on the show.
Yeah. What was your first computer?
Oh man, so the first one that I used was my father's original IBM PC 8086. So
Okay.
he bought one of those in the early 80s to do uh, chemistry simulations on. And I got to
Hmm.
use that to play Zork and play with some games in BASIC. The first one that I bought myself was a ThinkPad laptop in the late 90s that I installed Red Hat Linux 6 on. So that was not Red Hat Enterprise Linux, of course, but the original Red Hat Linux.
I also had, I think it was white box. I also had, I bought, you had to buy a box at a bookstore. And I think I started with Red Hat 5 or 6 because I built my own servers and I like Red Hat. I liked actually the UI and everything. So it was actually a nice experience with Red Hat back then. Not now as well, but back then
It was.
was huge. And you played games or what you did with the computer? Zork you already mentioned, but what was the transition from gaming to, I don't know, scripting or whatever you did?
Well, I guess like a lot of people of my age, and I think we're about the same age, games were kind of my introduction to programming because I was playing games and I thought I want to be able to build things like this. So yeah, my first game was a dungeon crawler in the vein of Rogue or Angband,
Hmm.
if you're familiar with that. And later on, in the early 2000s, I wrote an early web-based MMO. And since then, I've pretty much focused on distributed systems. And I remember one time an older programmer that I talked to, he said, I don't write games because they're not as interesting as the other software that I write. And I was like, how could that possibly be true? How could something be more interesting than writing games? But yeah, it turns out I agree now. I like distributed systems. I like databases. These are challenges that excite me.
Yes, and yeah. By the way, it's also my opinion. So for me, I was curious about games, but I knew that it's somehow very different to enterprise software, right? So this is why I never wanted actually. Actually, I did. I implemented once a game ASCII based on C16, I think, on Basic just for fun,
Right?
but was not really a game. But this was just because I wanted to see how it works and do something with the computer, right? So, but you started which programming languages you started with, and why you wanted to create a game or you had
Well,
different
so I mean,
motivations?
in the 80s and 90s, it wasn't so much like you picked a language after selecting from the vast menu of options you had. You picked a language because it's what you could afford or what could run on your computer.
Hmm.
So I used Turbo Pascal for a number of years, and then once I started having my own Linux system available, then of course I had Java and Python and everything else available. But at the very beginning, like the internet wasn't really a thing yet, and so it's you were literally buying software off of a shelf somewhere, and that's how I got Turbo Pascal.
Yeah, I started with ZX Spectrum, so there was only basic, but I also had 8086, and I could choose between Turbo Pascal and Comal, or very strange name. It was a basic like language, of course, basic QBasic, I think,
Mm-hmm.
from Microsoft back then. And there were lots of languages on disks, but Turbo Pascal was the most popular one. Everyone, they were like the popular choice to pick Turbo Pascal. And yeah,
Yeah,
so you wanted to create a game, right?
that's right. Yeah.
Yeah, cool. And which one? So is something special or just a game?
Oh man. So I mean, the earliest games that really got me hooked were the original Rogue, and then the original
Hmm.
Moria, and then the original Angband. So these are all kind of dungeon crawler games, and I'm still a fan of that genre. So to your listeners who enjoy gaming, who enjoy roguelikes, I need to give a shout out to a game called Jupiter Hell. It's by a solo developer. He's Polish. He spent a number of years building his own 3D engine, and then building this, true roguelike with grid-based movement, with permadeath. There's no meta progression, and I've spent over 600 hours playing this game. So I think you can make the claim. I will make the claim that it is the best classic roguelike ever made. And
Jupiter Hell.
Yes. Mm-hmm.
Mm-hmm. Actually, I remember of something. I worked with Polish developers, not Polish developers, but they had on their laptops a sticker. And I asked them about the sticker. And this is a game, something with wizards, I think. And this was a Polish game, very popular. And I did a research. There was something special about this game. Like, it was open source or not open source. Was also an interesting story. So the second one we mentioned is now a Polish game. But the other one was like, I forgot what it was. Something with wizards, I think. But everyone was delighted about the game. Okay, so you wanted actually to recreate Jupiter Hell back then?
No. So Jupiter Hell was released 3 years ago.
Okay.
Yeah, it's a modern game. So at the time, this was just like Rogue and Moria, text-based, ASCII-based games.
Yeah. So you saw the games and you wanted to do something similar. So I would like to extend it or whatever. Okay, cool. So you started with Tua Pascal. What was the next language and why you switched to it?
Let's see. The next language that I would say that I actually learned to be good at was Java. We'll skip over some unfortunate things in the first Web.0 period where I worked for a couple .bombs. But yeah, I would say Java was the next one, followed by Python.
Okay, in Java 1.0, or which version is it?
Yeah, this would have been, I don't think it was 1.0, but it was like 1.2. So pretty early on.
1.2 already with the proper collections. I think they were introduced in JDK 1.
Yeah, well, yeah. So I remember we had a bunch of codes that still used the vector class instead of list. Mm-hmm. So I think that code was written before I joined the company, but it was still part of the code base at the time.
And you joined the company and they already used Java, so you had to learn it, right?
Yes.
Okay. And what is your impression about
and
Java?
I'd used Java a little bit in school. So at the time I was like, hey, I prefer C++ because I kind of didn't know better. This is like my second job out of college. But I've never written C++ professionally, like gotten paid to do it. So I quickly got a lot better at Java.
Okay. And what the company did? It was e-commerce shop or?
This was actually a company that built software to run newspapers. So we actually had a GUI written in Java for Swing on the desktop to lay out your columns that would be printed on physical paper. So this was in 2001. So this was, even at the time, you could tell that the newspaper industry was not a growth market. But my first job had just abruptly stopped paying me. They didn't lay people off. They just stopped paying us, which is illegal, as you can imagine. But yeah, so I wasn't looking to be super picky about what my second job was.
Yeah, 2001 was tough already, right? So 2000 was the peak of the golden era, and then 2001 was a little bit problematic back then.
Right.
But still incredible. So it's like almost like a page maker, right? So what it did was like
basically page maker for newspapers, and it was super early collaborative system, so you could have editors working on it on different machines, but it was all going into the same database. So for its time, it was pretty sophisticated.
Yeah, even now, right? If you would write something like this in Java, you would be busy. I mean, it's not like trivial.
Right.
Okay, so and then, so 2001, what was the trajectory? So what you spent time? You stick with Java from 2001?
Yeah, so I guess to summarize a little bit, so I became one of the database nerds at that company writing Java code. And I really enjoyed, because that was actually our performance bottleneck. So I mentioned where people are collaborating on different machines, and that the way that collaboration works is everything's going through the same Sybase database. So
Sybase,
yeah,
is
I don't
unusual.
hear that a whole lot, but that's what we used. And so you had to be fairly aware of what operations you could do quickly versus what would be slow with the database. And a couple jobs later, I was working at a company that built backup software. And what I was doing was building the object store to hold the data in the backups.
Wow.
So this was based on Reed-Solomon encoding, so similar principle as RAID 5, RAID 6, but we did a 9 and 3 encoding, meaning that we had a total of 12 fragments of a file, of which 3 were parity fragments. So you could lose 3 fragments and still be able to rebuild the file from the remaining 9. So this means that you're saving a lot of money in storage compared to a simpler design like triplication. And the bottleneck for us was actually the database. So we had a PostgreSQL server, and we called it the feared massive database because, and the reason it was feared is because if it went down, like our business went down. So we did replication with Sloaney, which was state of the art for PostgreSQL at the time. But like it was still not a great feeling, being nervous for that database. And one of the things, this was in 2005, 2006, and you could see that as software switched from being something that you buy on a shelf and you install on your local machine to a service that runs in the cloud. We weren't saying in the cloud then, but it's the same idea. That more and more companies are going to run into this problem of, my database technology is built for, teams of 30 or maybe 30,000, but not 30 million. Like if you have 30 million users, your database doesn't work anymore. And so that's where I started getting interested in, like, how would you build a database that scales to 30 million users or more? And so my next job after that was working on distributed databases for Rackspace,
but back to the object store.
Yeah.
So object store is like S3 object store,
Yes.
right? So like okay. And you stored the objects in Postgres.
We stored the metadata, so the user accounts. We stored the user accounts in Postgres. If we tried to store anything related to the objects, it wouldn't have worked at all. So
this is what I wanted. It's like, okay, because bottlenecks like, okay, we have storing everything in Postgres, no wonder, right? So even with metadata was a problematic.
Yes.
Okay.
Yeah. So what we actually ended up doing was we took the metadata, like who owns which file. So one of the challenges that we kind of created for ourselves is that we wanted to do single instance storage, meaning that if you upload a video and I upload the same video, then I don't actually have to upload the bits a second time because it should say, oh, this is the same file that Adam already uploaded. And so we can take a shortcut and just store a pointer to that. And so we started off by doing that in PostgreSQL, and it just, like I said, it was way too much data. And so
this is what Dropbox did at the beginning. You remember at the beginning it was a hack. So that if you knew the hash, right, you could store the hash and the file magically appeared in your account. There was a hack at the beginning with Dropbox because they also did the same with.
Right.
It's also called consistent hashing, I guess, right? Yes. Where you can have the same ID or the ID is calculated according to the content. And then you have basically a flyweight or pattern or singleton pattern. It's only once, right? So this is okay.
Yeah, just for the people who are interested in distributed systems, this is called a content-based hashing. And consistent hashing is when you have a distributed system and you want to have a token ring and keep those moving as little as possible.
Content-based hashing, you're right. Content-based hashing is also what Docker does with layers and content-based hashing. And you implemented it. The values were stored in Java, right? You wrote Java software as well?
So that would have probably worked better. And actually, this was where I got into Python. So
Okay.
They had made the decision.
We will cut it out, this section. So
okay. Yeah, this is actually the last job I had where I didn't get to make the decisions on what to build something in. But they made the decision to use Python, and I was actually really interested in Python at the time. This was, Java tooling was starting to get good. You had early versions of IntelliJ, but you also had Java. The Java community was very J2EE oriented at the time, and so there was a lot of I would say ceremony to do things, a lot of boilerplate. And I didn't love that. I felt like it made me less productive. And so I was looking to explore something different, and Python was very different. So this was written in Python, and the reasoning was that since it was I/O bound rather than CPU bound, that it would be okay to write it in Python, and Python's shortcomings in performance wouldn't matter so much. That turned out not to be true. Primarily, actually, in terms of like the actual computation, that part was pretty much true. The big problem we ran into was that the Python virtual machine is much, much less sophisticated than Java's. And so there was no, and I believe, I may be incorrect on this, but I believe there's still no compacting garbage collection in Python. So once you start fragmenting your memory, your heap usage or the equivalent just grows out of control, and it never until you get killed by the Linux killer. So we were rebooting or restarting our services on a nightly basis, just roll through the cluster and restart them to keep from that becoming an issue. So that was actually, I think, a little understood problem with Python, and probably still not very well understood because people don't try to write that software or that kind of software in Python very often.
Yeah, it's interesting. So after that, you didn't like Python that much anymore, right?
Well, yeah, I mean, I guess I have a more nuanced appreciation for where it's good and where it's not so good. And, fast forwarding to today, I'm really a big fan of where the Java architects have taken the language over the past few years with record classes and the destructuring. And it really feels like they've delivered on their goal of taking the best ideas that C# and Kotlin and other languages have tried out and pulled them into Java once we understood them well enough to not regret. Maybe doing some experiments that some of the new features don't go as well as planned, and so Java gets the benefit of being a fast follower rather than being an innovator.
Almost an Apple-like, yeah. Yeah,
I guess that's an analogy that I hadn't thought of, but yeah, I agree with that.
Yeah. Same here. So I have to say, I really enjoy modern Java. Java 21, 22. I cannot wait now for string templates. They are around the corner. And I even use Java for bash scripting, basically. So automation tooling, and it works surprisingly well. I mean, a few lines of code, no ceremony, no dependencies, and you can achieve a lot, which is remarkable, right? So this is what I really like.
Yeah, that is remarkable. You're more hardcore than I am. I go back to Python when I need a 5-line shell script.
I wanted to learn Ruby, and I like the aesthetics of Ruby and also the story, with back then Sun Microsystems and Ruby and a little bit Ruby on Rails and the entire story. And I don't like how Python looks like. So I wanted also to learn it. Never had time because lots of to do with Java. So I think, but I still would like, to try it out, but I need a use case. The problem is whatever, if Java is working, I will never try Python. This is the problem. I also wanted, to learn Scala. It was, okay, I would really like to learn it, but there was no reasons, actually. Java was always fast enough, and now I don't regret it, actually. So I just use it Scala test once, and it was very slow. So okay, this is not for me. I am too impatient, I just used Java again. So yeah, this is so it's actually a great story, right? If you, with Java, you only have to wait, and it gets better and better over time.
It does, yeah.
Okay, what happened after the Python? What is the next job?
Yeah, so that's where I got
Mhm.
back to Java. So Rackspace hired me with a mandate to build
Okay.
them
Mhm.
a scalable database, and so I got to look at this is in the fall of 2008. So I got to look at and the other thing Rackspace said is you don't have a budget. Like it's like you and three other engineers. So that's the team. So it's like, okay, obviously I'm not going to write something from scratch. I need to build on something open source. So I got to evaluate HBase. MongoDB was around at the time. Facebook had just open sourced Cassandra. And then there's a couple more that you don't hear much about anymore. Like LinkedIn had something called Voldemort.
Voldemort, exactly.
Yeah.
Mhm.
So yeah, I got to look at what was out there, and I really liked Cassandra's.
And Tokyo Cabinet, you remember this?
I do,
Tokyo.
yeah. I believe, if I
Tokyo
remember correctly, Tokyo Cabinet was the key value store, and then there was something that sat on top of it to make a distributed system, but I don't remember what the name was.
And Voldemort was huge. Cassandra less so at the beginning. So the Voldemort, I remember, is from Harry Potter. Someone, right? I guess. Yeah, exactly.
That's right. Yeah. So yeah, that was actually one of the downsides is that nobody was using Cassandra. Facebook had open sourced it, but it wasn't like we're open sourcing this and we're going to build a community. It was more like we're open sourcing this to show how cool we are, and they kind of used it as a recruiting thing. It's like, hey,
exactly what Netflix did, exactly back then, right? So, yeah.
Yeah. So I did go into it with my eyes open that, hey, if I'm going to invest in Cassandra, I'm going to need to build the community as well as write code. But I'm pretty happy with how that turned out in retrospect. I really liked the combination of simplicity and power that Cassandra had and still has. And I think that even in 2024, nobody else has built a system with the combination of performance and reliability that Cassandra has.
Yeah. So you started at Rackspace and you took a look at HBase, MongoDB, Cassandra as well, or?
Yeah, so Cassandra had been open sourced. It wasn't part of Apache yet, but it had been open sourced, and so I basically forked it. And when Facebook did contribute it to Apache, and one of the things about the Apache Foundation, as you may or may not know, is they value creating something that's not a monoculture. So they want projects to have developers from multiple companies working on them. And so the Apache mentors were looking at Cassandra and like, okay, this is cool, but like everyone works for Facebook. And so I approached them and I said, hey, I'm the closest thing to a non-Facebook expert on Cassandra that you'll find. I've been maintaining this branch with bug fixes and new features, so you should make me a committer. And they did.
But you did it for Rackspace, right?
Yeah, this was while I was at Rackspace, yes.
And why you had to change Cassandra? Why you couldn't use it out of the box?
Well, it was built to run Facebox's inbox search. And so anything that you didn't need for that probably didn't exist. For instance, the first, I believe Cassandra ticket number 1 over in the ASF Jira is adding support for performing deletes in Cassandra. So even like basic things like that didn't exist.
Okay. And why you decided to use Cassandra? Because you thought, okay, it's interesting. This is like there's no community, and this is the the chance to do something.
Yeah. So fresh. The no community was definitely a drawback, right? Like other things being equal, I would be happier if I could just write code and leave the evangelism and the community building to other people. But I do feel like I can do that if I have to, and in this case, I accepted that I would have to. I forgot the rest of where the rest of that was. That was a two-part question.
Yeah, I also forgot, the question because I thought about the community aspect. So I asked you why you picked Cassandra.
Oh yes, why I picked Cassandra.
Yeah, and because of there was no community, but what was the technical reason? Maybe
Yeah, the technical reason, I think I can summarize it pretty quickly. So fundamentally, I did not want to build a database that was built around a master-slave architecture, because that kind of architecture is much more fragile, and to recover from failure, everything needs to go right. And I had enough experience from production systems building this object store that I knew that everything does not always go right when you're trying to recover from a failure. So I really didn't want to touch that kind of design, which ruled out MongoDB, and it ruled out Couchbase, and it ruled out a lot of the systems. So if I was looking at the leaderless, fully distributed systems, then it was basically Cassandra and Voldemort, and there was one at the time called Dynamite that was written in Erlang, if I remember correctly. But I did like the other ones besides Cassandra. Everyone else was just building key value, and Cassandra said, "Hey, we're going to give you rows and columns, and we'll perform conflict resolution at the column level rather than at that entire row level." And so that was the other thing that I really liked about Cassandra.
What I find interesting is that Cassandra is very similar to DynamoDB from Amazon. So I guess it is based on the DynamoDB paper, I guess. Right?
Yeah, so there's a family tree that kind of has a fork, right? So there's the original Dynamo from 2006. And then the authors of Cassandra said, "Hey, we learned a bunch of lessons from Dynamo." I believe 2 of them were from that Dynamo team, and then went over to Facebook.
This is interesting, because I always wondered why they are so similar.
Yeah, and so they said, we're going to take some of those lessons. It's going to be an eventually consistent leaderless system, but it's not going to rely on developers managing vector clocks for conflict resolution. We're going to do a simple last right wins, but we're going to break up the atom of storage into these columns rather than just being a single opaque value. And so then at the several years later, Amazon said, "Hey, we need to have a database as a service that's much more performant than SimpleDB," which was their first attempt at that. And so they took a bunch.
By the way, you can still order the SimpleDB. So this is it. Yeah. If you search for SimpleDB, you will see an ancient page. It looks really like 1997.
Well,
so it's interesting.
So that's one of Amazon's superpowers, right? Is they don't remove services almost never. It's like the opposite of Google, where Google's like you've got the Google product graveyard, where didn't get enough traction. All right, we'll kill that. Amazon's like, no, we'll if you're using it, we'll keep it on for you. Almost like I do remember just a couple months ago that they finally got rid of some service, and they were like, "Hey, we're really sorry about this. This is going away."
The Code Star, right? So the Code Star, it was like a replacement. This was like the code tools, source code tools. There's the connection remained, but the Code Star family was shut down.
Yeah. So it does happen, but very, very rarely. And I think that's part of the reason they've been so successful.
Yeah, okay, this is cool, actually, learn something, because I always wanted to ask someone why Cassandra is so similar, and this is what I suspected. There was the origin DynamoDB paper, because I remember back then I also did some NoSQL courses, and they were also based on the papers. Okay, because this is, the origin paper, I think. React database was also based on the idea back then, I remember, right? And why I like Cassandra is because it was pure Java, and for me this was a huge thing, because you run Cassandra, the same. So I like actually J2E back then, and still Jakarta and Microprofile. I use Quarkus a lot right now, which is very similar to J2E or Java E back then. And we had already, the the platform to run Java, and Cassandra fit well because it's just Java. We had the JMX monitoring, everything was in place.
And we still sometimes get pushback, like, why would you write a database in Java? But I think this is actually a really good fit for Java. Is that compared to, you mentioned Riak, like Cassandra was 10 times as fast as Riak because Cassandra was written in Java and Riak was written in Erlang. Like, it's just much faster. On the other hand, you had a company called Hypertable where they built a clone of Bigtable in C++, and their development moved at a snail's pace because they were writing in C++. So I do think that Java is a great, it's a great environment to be very productive in while still being able to deliver high performance.
Yes. So, okay. So you became committer of Cassandra.
Yes.
Because of the work at Rackspace. There was like a slogan, fanatical support or something.
That's
like
right.
This, right?
Yep.
This was, okay. This is the company. Okay. And so what happened then?
The medium length version is that we had a company on the mailing list, on the Apache mailing list, talking about Cassandra and how they were going to use it in their telecom project, and then they stopped sending emails to the list, and I was like, what happened? So I reached out, and they said, the lead engineer said, my boss told me I can't use Cassandra. We're actually going to go with Riak because I can buy a support contract from Basho, which was the company behind it. So, oh wow, so not having a company behind Cassandra, like, this is a bug, and I need to fix this bug. So that's when I started DataStax to be a commercial source of support for Cassandra.
Mm-hmm. When was it? Which year?
This would have been in spring of 2010.
Okay, so you stopped, working on for Rackspace, so you quit, and then you started your own company and provided commercial support. Mm-hmm. Commercial support is actually huge. I have to say. So back then was the same story with application servers. Lots of my clients, because if you don't have a support, you cannot patch the thing, right? And it is not that. The main problem is not even that you cannot do it from the technical perspective, but it's also important to have something from the political perspective, organizational perspective. So look, we have a company which cares about the patches. Done. We don't have, to plan it, to schedule. And for me, it was always important, to have the supported base infrastructure. And open source is fine, is free, but support costs time, and either you have time or you have money, I would say. So you cannot just spend time patching stuff. And by the way, I was in a mission critical project back then. It was 2003, and the decision of the company was to support JBoss by their own without JBoss. It was before Red Hat, I think.
Right.
And there was one full-time job. Developer did nothing else, than just patching the JBoss and looking for the patches, which was absolutely fine, but it is not cheap, right? So this is not like, this was a valid strategy, but not money-saving strategy. It's more expertise, it's okay, we would like to fix everything by ourselves. But I think there is no strategy just to saying we download, an open source thing and hope it will work. This is a little bit crazy, right?
Right, yeah, and so I was completely fine with, I still am completely fine with working with people who are saying, hey, I'm not going to pay for support, but I'm going to, file bug reports. I think for some non-technical people, they think, oh, you're open sourcing it because you're going to get people to write code for you for free. Like that almost never happens. But you do get bug reports for free. More often than not. And those are still super valuable because, every bug report you get from the community is one less that you have to track down with your QA team. So, I remember the CTO of Spotify, and I don't think I'm breaking any NDAs by repeating what he said, which is Spotify never pays for open source. Like, we just don't do it. But I was still really happy to have Spotify using Cassandra because their engineers were filing bug reports. They're giving talks at the Cassandra Summit. So yeah, like completely fine and welcome participation from people who never intend to pay for it. That's not the only way to contribute to open source.
Mm-hmm. And so over the years, so you committed a lot in Cassandra. So I took a look, at the commit history. So the most active you were 2016, 2017.
Yes.
And what I remember is we also look at Cassandra for this was a Zenzo project. So this was like it was a time series, I think, because what we could do with Cassandra is we could pick a column and we saw all the data at once.
Right.
And I suggested we actually started a proof of concept with Cassandra, but for unknown reasons they choose Elasticsearch, which was actually not the best choice in this project. So it was really challenging. But we did some evaluation with Cassandra. And I always made fun, at the beginning, because I said, okay, no one would like to have NoSQL. Also, NoSQL was like the thing, right? So they say, NoSQL, you don't need SQL. And Cassandra had CQL.
Right.
It's like, look, this is... And what I also remember at the beginning, there are lots of Twitter clones on Cassandra, right? So the canonical examples for Cassandra was a Twitter clone, I remember as well.
Yes,
I don't know why.
That was true. The Twitter clone was a good way to kind of present a time series oriented data model, which is something that Cassandra was good at.
Okay, so what happened? Which features Cassandra has right now? So because over time, you did something between 2008 and 2017,
yes.
and now as well. But what you worked on?
So,
or what was your idea?
Let me mention what happened there, by the way, because you accurately identified that I stopped contributing to Cassandra for all intents and purposes around 2017. And basically, I went from leading the Cassandra team to being more of a manager. And in fact, I was VP of product at DataStax for a couple of years. And the reason I did that, I'm not sure if I would do it over again. But the reason I did it
this was my question, whether you were happy.
Yeah, no, I was not happy.
Question
that's an easy question.
To all managers.
Absolutely
to all
not
coding
happy.
managers. Okay.
But the reason I did it, and the reason that maybe I would do it again, is that my attitude was, hey, I started this company and I want to do whatever I can to give it the highest chance of success. And if that means that, DataStax needs me to be VP of product or whatever else, then I will do that for the benefit of the company. But no, that did not make me happy. And in fact, I was towards the end of playing that manager role, I was getting up in the morning on Monday and looking at my calendar for the week with just meeting after meeting after meeting. And I was giving myself depression. It was really a mental health issue for me. So I actually took 2022 off. I took kind of a sabbatical year, stepped back from DataStax, spent the year making generative art, actually. So I still got to...
With Tyler Hobbs?
So Tyler Hobbs is a good friend. Worked for me at DataStax. And one of the most successful generative artists in the world. I never did a collaboration with him, but we did talk about some of the techniques at times. But I was writing art with OpenRender, which is Kotlin based. And so it can actually compile down to JavaScript and run in the browser or run on the JVM on your desktop. Really, really good framework. Lots of good things to say about that. But yeah, so I took the year off, wrote some art, and then came back to DataStax. But I said, hey, I'm done being a manager. I want to write code. And so I ended up writing JVector, which is where we kind of extracted our vector search logic into. So that's open source as a standalone project. It's used by Apache Cassandra for vector search, as well as DataStax Astra's hosted Cassandra service.
But you are CEO of DataStax.
No. I was smart enough not to do that to myself.
Okay.
So yeah, I'm chief technology officer, but I mean that's kind of a formality. Like, hey, I'm a founder, so I should have a title that starts with a C. But really, I'm writing code, I'm doing code reviews, so I'm back in the trenches as an engineer now.
I always wondered why there is no vector databases in Java. I say this is crazy. I mean, this is we had I thought even DerbyDB, H2, HSQL, and all the small databases. Okay, there is nothing, and I didn't even look at Cassandra because it's too big. So Cassandra was like the enterprise software, and then I found JVector actually, and it is popular. This is over 1,000 stars, one and a half, I think, on GitHub, which is big, right? And looks really interesting. And you are hyperactive on JVector. It's actually, this is exactly what you said, right? It was the peak was 2016, nothing, and then JVector happened.
That's right.
And what's also interesting is, but this is a completely different story, is Apache Pulsar actually, because Pulsar had features which Kafka didn't have, right? So the tiered storage, for instance, I remember it was a few years ago. So again, tiered storage in Pulsar is a huge thing, right? And everyone ignores that. So no one talks about Pulsar back then. And this is also wondered why everyone mentions Kafka. Even on my AXTV streaming show, I mentioned it several times. And Pulsar is also an interesting project, very similar to Kafka, with built-in. This is how to call it, functions, right? So the not user-defined functions, almost like serverless functions. I forgot the name.
Yes,
and
that's just what they call
streams.
Pulsar functions.
Oh, okay, Pulsar functions and streams. So streams means you can have like joining the stream. So higher level, not just byte shifting, which is a little bit boring. More like higher level operations. So were you also somehow did something with Pulsar or?
Yeah, so this was when I was wearing my manager hat. So DataStax did invest in Pulsar, hired a team of 20-ish people working on Pulsar, all told. So that's not just like the engineers, but that's like the evangelists and the support team and everything. And yeah, so we invested pretty decent amount into Pulsar. Primarily, you kind of touched on that with the tiered storage. I would generalize that a little bit to say that Pulsar separates compute and storage much better than Kafka does, which means that you can scale them independently of each other. And for companies where they have a lot of archived data that they want to keep around, that's very important, and tiered storage is part of that. So yeah, I felt like Pulsar was able to learn some of the lessons from Kafka, like what worked and what didn't, and design a new system that didn't have some of the same weaknesses. So yeah, I'm a pretty big fan of Pulsar, but I haven't written any code for it.
Okay. By the way, a separation of storage and compute, I think this is really important also for databases in the cloud, right? Because most of the clouds already have highly distributed or not distributed, how to call it, consistent and persistent storage, reliable storage. So if you're able to separate this, so the cloud providers can pick the clustering for you, data replication, and you can just run compute on top of the storage, like Aurora, for instance, serverless, right, from AWS or right. All the
So I mentioned that DataStax has a Cassandra service called Astra, and to build that, we actually took Cassandra apart and put it back together in a pretty different way, because Astra uses S3 as the durable storage, and then the nodes that we spin up are only caching data to reduce the latency of serving that. But yeah, for a multi-tenant cloud service, it makes a lot more sense to build it in that kind of way versus the locally attached storage that classic Cassandra uses.
So Astra is using S3 as a storage?
Yes.
So this is actually perfect, right? Because this is cheap and reliable. So it is
exactly, yeah. Really, like the devil's in the details, but yeah, I think that's the right way to build a database in 2024.
Yeah, perfect. I remember something. What I remember in the early Cassandra days, I look at the architecture, and what I remember is that Cassandra, maybe I'm wrong, but what I remember is that Cassandra was faster with writes than reads. So what Cassandra did, Cassandra wrote in a kind of a cache, and then the cache was in a couple of caches, and they were asynchronously persisted on disk. And with reads, I think you look up right in the cache and then in the persistent storage. So reads were a little bit slower than writes, which was incredible back then.
Yes, and yeah, that was true early on, mostly because we spent close to zero effort optimizing the read path. So okay. I would like to say, I would like the record to show that Cassandra reads are faster than writes now, but it's still the case that Cassandra writes are faster than almost anyone else, because it is like you said, we're appending to the commit log, we're putting it into the memory pool, and we don't have to look up any leaf nodes in a B tree. The design lets us just throw it into the commit log in the memory pool.
So you removed the sleep from reads, right? So there is no more.
That's right. And then we took the sleep out. Yeah.
Okay. We should at least start with the JVector, because this is what really interests me. So this is the you started to work on JVector. So the question is how you started to do this, because you have to understand first, the multidimensional vectors, to do some research. So how you start such a project, maybe?
So I guess one of my superpowers is hubris, and actually that reminds me of Larry Wall from Perl. He liked to say the three virtues of a programmer are laziness, hubris, and what was the third one? Is it impatience? Anyway, hubris is one of them. And so the hubris to say, like, hey, I can do this. Like, I can learn whatever I need to learn, even if I haven't done it before. And so that's basically where JVector came from. I have no background in machine learning or approximate nearest neighbor search, but I thought that I could learn it, and I did.
Mm-hmm. And it sounds interesting. I mean, this is also huge now, because what it means. So why vector databases are important? Because this is the similarity search. Right. So we need them to find semantically similar things, and semantically similar means even a picture and a word. Because if we would use, for instance, Elasticsearch or OpenSearch, they are more or less searching, for ASCII. So this right. ASCII comparison, and semantic means meaning. So you remember back then this 2003, 2004 RDF, this resource description framework. This was the attempt, to have semantic search
web, yeah.
based semantic web, exactly, and the graph based knowledge. And 20 years later, we have the vector database, which works differently, right?
Yes. And so I would back up even a little bit more for some of your listeners and say that, the reason we care about semantic search at all, especially in 2023, 2024, is that when you're working with a large language model for generative AI, if I go and I ask GPT-4 and ask it to describe Cassandra's unified compaction strategy, it can take some pretty good guesses, and most of what it writes is correct, but it does sometimes make things up when it's less sure. But if I give it, here's the documentation for unified compaction strategy, now summarize it for me, then it's much more accurate and much less likely to hallucinate. And so this is where, this is called retrieval augmented generation, that I'll go and I'll take my query and I'll go through some kind of database of potentially relevant documents, and I'll use that vector search to find the most relevant ones and give it to the language model and say, here's your background. Now answer this question using that background.
Or even we can even go one step further with RAG, because what you could do, you can say, look, the answers are in my own database, and this is the link to the database. So there's no more. You can eliminate hallucination entirely, because maybe the AI or LLM picked the wrong link, but at least this was based on this link, and you can decide, okay, is it the information correct, or is it useful for me or not? And I think RAG is huge, and RAG is needed because of the context window is too small. And what RAG is doing, right? I think you are just
there is the limitation of the context window. It looks like that's going away. It's starting to go away. So with GPT-4, you have 128,000 tokens. With Claude, I don't remember what Claude is. Claude is more.
200K or whatever.
Yeah.
But yeah.
And then Gemini Pro, they're saying that they're going to allow up to 1 million. My understanding is that's gated to a few beta testers right now, but it's coming soon. So I'm really happy to see that limitation going away. But the other limitations, the reason why you would want to use RAG instead of just saying, here's the entire database, now find the information I want, there's the performance and the cost. So the latency of getting an answer from the LLM is directly proportional to how much input you give it, because it actually processes each token. Like if I have 100 tokens in my input, to generate the next token of output, it's actually processing 101 tokens. To generate the next token of output, it's processing 102, and then the next is 103. So it gets slower, in proportion to how much input you give it to process. And the other thing is that each of those processing steps is also costing you money, because that's how the unit of computation works. So for latency and also for price, even if I had 1 million context tokens tomorrow with Gemini Pro, I would still want to do the majority of my work with RAG to have my queries back in a fraction of a second instead of 90 to 120 seconds.
And you could even use a local model like Olama or Mistral or whatever, so you don't need to send something with a vector database. And you're right. So I use Claude a lot and ChatGPT, and for larger texts, so not even larger, like podcast transcription or whatever, it takes 1 minute, 2 minutes sometimes. So it is way too slow, to be interactive. Still useful, but it's getting slower. So the problem I have is lots of interesting questions we cannot, I cannot ask you because it's going to be too long. For instance, why JVector scales well to 32 threads and not more linearly, right? So why is the 32? Why it's the limit?
So first of all, I'd be delighted to come back in a month or so and nerd out on the details of JVector. But the short answer to that one is that almost everyone builds. Well, let me back up. Can I give a medium length answer to this?
Yeah, sure.
The medium length answer is that there's two categories of vector indexes. You can build it by partitioning your data set and then picking the closest partitions to your query to search exhaustively. Or you can build it with a graph-based approach, which in practice, this is an interesting thing. And part of why I think this is such a fascinating place to work right now is that most of the research that you have coming out of academia is focused on the partitioning side, whereas the most useful practical systems are all graph-based. So if
Mhm.
any vector database, commercial vector database that you can name, they're all graph-based, because graph-based approaches are faster and they tend to provide higher relevance results with less tuning necessary. And so almost everyone builds those graph-based indexes with a locking strategy. Because when you're adding new data to the index, you need to figure out which edges should I remove to make room for this new one, and what nodes should I connect it to with new edges. And so they take the approach of locking the nodes that they're touching to prevent race conditions. And that, of course, taking out locks is a expensive thing to do, and it hurts your concurrency story. So JVector is the only one that I know of that takes the approach of using non-blocking concurrent data structures instead of a pessimistic concurrency control. And I think a lot of that, the knock-on reason, this comes back to what I said earlier about Java being this great intersection for productivity and also performance. Years ago, I read an article by Cliff Click, who was one of the architects of the Hotspot VM.
Azul.
Yeah.
He also worked. Yeah, exactly.
After leaving Sun, he was at Azul. Yeah. And he said many concurrent data structures are difficult to impossible to build unless you have garbage collection because of the reference cycles that you run into. And so, I think that's a big reason why everyone who's building vector search in C++, it's just way too difficult for them to take a non-blocking approach. But fortunately for me, I'm not writing in C++, so I have that option.
You could still pick Python,
Yeah, I could do that, and it would be very, very slow.
The full cycle down. There are also other fascinating questions. Project Panama, what do you decide? So this actually, I would say it is great because this is like Cassandra 2.0, the same story. Cassandra back then was like an alien technology, very, very fast and complete different. And now JVector is also similar from my perspective, right? Last question. Have you looked at LangChain for J? You are muted now.
Sorry about that. No, I actually haven't. I haven't looked at LangChain for J.
LangChain for J is like LangChain for Python, but written in Java, and it gets more and more popular, and also integrates with various vector databases. And I had a chat with them because what I don't like, what they do, they spin up Docker, and I say, okay, this is a little bit boring. So you should integrate an pure Java solution, because what you can also do with LangChain, you can even use GraalVM to cross-compile it to native code, the entire thing, and regardless whether it works with JVector or not, but at least I would have everything in Java, no Docker, nothing. And it is well integrated with Quarkus. So what it could do is actually create a package Quarkus as AWS Lambda, and have like the serverless facade to my model, which is really great, because there are even Java is getting more and more to LLMs as well, integration. So you could use Java.
Actually, I saw. Yeah. I think on your last episode you had you discussed briefly llama2.java.
Exactly.
And so I actually work with an engineer named Jake Luciani, and he's written something called JLlama, which is llama2.java is a port of llama2.c, which is a single purpose runtime that's really intended more for teaching than for high performance. And JLlama is more inspired by llama.cpp, which is the one where they're like, hey, we want to make this run fast. So JLlama has flash attention, for instance. It has quantization built in. It can quantize at runtime if your model isn't already quantized. So my dream, not yet realized, but my dream is to take JLlama and JVector and wire those into IntelliJ so that I have a local copilot that's all running in Java.
this is your dream, so leisure dream, but for enterprise companies, also big thing, because there are lots of Java projects out there, and it's always the question, how to integrate with AI and LLMs. And if you have something pure Java with not a lot, dependencies. Meanwhile, I never liked dependencies, but we know with Log4j stuff, which happened, no one is excited about dependencies anymore. The less you have, the better it is. So I would say, something like LangChain4j with a small set of controlled dependencies and platform you already have, I think Java would be stellar, and Java is also very performant. So
absolutely.
So perfect. I have to invite you back because we have to talk a little bit more about JVector and if you like, too interesting. Just JVector maybe, and it would be good enough. Where people can find you or how they can buy, data stack services or whatever you have. Just please share, your
sure, yeah. If you just Google for DataStax Astra, then you'll come to our database as a service that I work on. And then of course, if I'm pretty sure JVector, the Java project, is the top Google hit for just searching for JVector now. So both of those should be pretty easy to find.
And you're also on Twitter, right?
I am on Twitter and my tag is spiced with a Y, SPYCED.
Okay, and Blue Sky maybe? No,
I haven't taken the jump to Blue Sky or Mastodon or anything. My son's trying to get me over there, but I haven't yet.
Yeah, Blue Sky is actually nice. This is like Twitter was at the beginning, so this is like a Twitter clone, but lots of Java developers actually there. So
all right,
it's also a nice place.
I'll give it a shot.
So thank you a lot.
Thank you as well, Adam.